Thank you, thank you. Hello, everyone. It's really nice to be here. A lot of familiar faces. First time in Warsaw, first time at Energy Tech Summit. Thank you to Contrarian for having us. And yeah, really really looking forward to having a cool, casual conversation about batteries. Something that I'm very, very passionate about. And just, who the heck am I? I'm Nicholas. I co-founded an organization called Intercalation, working on research publishing and angel investing in the battery space. And so super exciting to speak to everyone here today who has something to say about batteries and, hopefully covering everything in the battery value chain up from battery raw materials and anode manufacturing, cathode manufacturing, and using these batteries and thinking about how to use them best in end applications, because ultimately we're not making batteries just to make batteries. We're making them and thinking about what we want to use them for in the future. Phones, laptops, cars, planes, maritime, the list keeps growing. So really exciting to dig into it with everyone here. Thank you for joining me. And I would like to just first start off with some introductions. And we love being interrupted, so if you want to interrupt someone, just feel free and go ahead. But why don't you start, just talk about who you are, what company you're from, and why you're trying to disrupt battery manufacturing today.
Sure. So my name is Fern. I've been in the battery space for a while, first at Apple, working on battery procurement in the materials space, and I'm here representing Mitra Chem. And what we're working on at Mitra Chem is integrating our machine learning and software platforms into the physical science research space on battery cathode materials. So our product is iron-rich cathode materials, LFP, LMFP, and our cornerstone product, LMX. And our differentiator is our machine learning acceleration platform that allows us to perfect these materials and bring them to scale more quickly. And what we're really tackling is just the pace of innovation in the industry. So it can be about a 5-year time horizon between ideation and execution on a cathode material, and that's before it really gets integrated or qualified into the space, and we're trying to bring down those timelines.
Sarah?
Hi, everyone. I'm Sarah, co-founder, CEO of a company called Infyos. Our focus is on working with battery players and other across the supply chain to help them manage the ESG performance of their supply chain and be ahead of regulations coming into place like the EU battery regulation this year and also Inflation Reduction Act in the US, so that they can make sure that not only are they able to scale up batteries as quickly as possible, but that they can scale them up as sustainably as possible at the same time. My background has always been in supply chains and sustainability, but also working out in China and building technology companies in China, which obviously has a big relevance when you're talking about batteries and their supply chains.
Hi, my name is Kory. I'm a co-founder of Battrion and in charge of operations and strategy. What we are doing is we've developed a fabrication technology for lithium-ion batteries, specifically for the anode, so for the negative electrode of your lithium-ion battery. It's the part of your battery that limits fast charging. And so what we are doing is we are aligning graphite particles to allow for faster charging. So our customers are cell manufacturers that want to essentially improve their performance of their batteries without changing essentially anything, right? So Paul will talk about that later on, but one of the fundamental issues is going to be being minimal invasive to have a benefit at the same time. So our product is a fabrication technology to improve lithium-ion batteries.
Cool, and then thanks. I'm Gavin, one of the co-founders and the CEO of a company called Batton. And Batton is a battery software company based out of London. And we make productivity tools to help cell manufacturers and battery pack designers design cells and systems more effectively. But our core IP as a company is that we can actually measure batteries really accurately. So we measure things like the electrical properties, the resistance of the battery, but we also measure how the battery degrades and some of the fundamentals associated with that. So we provide very, very deep technology to lots of other companies in the battery space. And to date, we've been trading for about 1.5 years. And in that time, we have 10 customers across material developers, cell manufacturers, automotive OEMs, motorsports companies. But yeah, looking forward to discussing more about battery manufacturing.
Awesome. Thanks, everyone. And I want to start with the raw material side. So I'll start with you, Fern, and just tell me more about LFP, LFP has been around for 20 plus years. What needs to be changed about LFP, and why is it so interesting?
Sure, yeah. So I'll kind of start off with what is LFP and why is it relevant. So LFP is lithium iron phosphate. It's an iron-rich cathode chemistry. What you hear a lot about in the electric vehicle space is the competing chemistry NMC, which contains nickel and cobalt and manganese. And the reason that LFP has come to light recently and why we're tackling it as a company is because it doesn't contain nickel and cobalt. So these two materials have seen a lot of price fluctuation, and that's a reflection on impending material shortages and complex supply chains on both of these materials. So cobalt is mainly sourced out of the DRC, meaning there's a variety of different human rights issues. It's mainly processed in China, leading to other geopolitical issues and leading to a lot of cost volatility. A lot of high purity nickel is coming out of Russia, about 20%, again, leading to some supply chain issues and again, cost volatility. And OEMs are really looking for other tools in their quiver of solutions to be able to execute on that don't expose them to these cost issues. And so that's really what has given rise to LFP. Beyond that, I think a topic that we don't discuss a lot that is really worth raising is safety. As we see more electric vehicles on the road with increased pressure on energy density, we're seeing continued safety issues and recalls. And I think most notably, we can look at the Chevy Bolt recall. And LFP, due to its polyanion structure, really has safety benefits, meaning the temperature that will cause a runaway reaction or essentially an explosion is much higher for LFP. And the heat released is much lower as compared to a comparable NMC battery. So that's really around the importance of LFP. What we're working on to bring these iron-rich kind of cathode materials to the next level is the energy density of the material. So LFP really comes at a discount compared to NMC at the cathode level when it comes to energy density, and what that translates to is limited range on the vehicle itself. So what we're working on is integrating manganese into the cathode lattice, which has a higher voltage and therefore about 10% higher energy density at the cathode level. And our cornerstone product, LMX, is really built to be able to compete with NMC on an energy density perspective while maintaining the low cost, supply chain security, and increased safety of LFP.
That's really cool. And when I think about LFP, I think a lot about Asian countries. Mm-hmm. And now that a lot of the LFP patents have expired, now the whole world is open to manufacturing LFP. So how do you see Western countries catching up to the 30, 20-year head start that China has had, for example?
Yeah, this is such a great question and so top of mind for a lot of US and European players. So when we think about supply chain resiliency, we think about diversified supply chains. And in a lot of cases, OEMs will have diversified cell manufacturing, meaning that they're sourcing from a lot of different cell manufacturers that may be even geographically diverse or producing in different countries. But what often happens is all of those cell manufacturers are purchasing from the same cathode vendors, and those localized supply chains that cathode vendors are sourcing from are even more concentrated. Meaning that when we have these rolling shutdowns due to COVID or geopolitical risks that we've seen in countries like Russia, as we've had conflicts rise there, and China as well, it leads to these massive disruption in the downstream supply chain. So when we think about kind of the next stage of EV innovation, what we're really seeing is a diversified approach, where OEMs are trying to ensure that they're sourcing from multiple different players and multiple different countries, not only at the cell level, but also at the cathode level as well, meaning that there's a lot of diversification in the US and in Europe, where there's all of a sudden an opportunity for young cathode players to come to light in the space.
Makes a lot of sense. And I think that's really interesting on the cathode side, and I want to flip over a little bit to the anode side. Once these battery materials and powders have been made, they need to be processed and coated into the start of the battery manufacturing process. So Max, I want to flip it over to you. Just tell me a bit more about how coatings are done today in battery manufacturing and why it needs to change.
Right, so the anode production is pretty much the same as the cathode production. I just want to give a rough kind of frame in which all of this happens, which is the key word here is roll-to-roll processing or economies of scale. So the battery manufacturers have to do whatever they can to make sure that everything is super efficient, right? So you start out with your slurry that is made out of your raw materials, and then it goes into the processing, into actually putting that slurry onto a current collector. In the case of a cathode, it's an aluminum current collector. In the case of an anode, it's a copper current collector. And then you go and essentially, once you've coated the slurry on it, it goes through a drying process and then essentially is dried. Next step is calendering, so it's pressing, and then it's going into the next steps, which is slitting, punching the electrodes, or again slitting, and then going in the actual cell with the cell assembly and separate everything together. Yeah, and so what we do is we have a process that goes in the coating step. So once you have a slurry that is put on your current collector, we can then, with our technology, align these graphite particles to then essentially have an electrode that has graphite particles being aligned, and that has a direct impact on the charging speed. And so what you see in the industry right now is kind of like going into different directions. So on one hand, you have one extreme that is really going into dry electrode coating, so reducing the amount of capex that you need to employ, and then there's other inventions, but maybe we'll touch upon them in a second.
Yeah, absolutely. It's really interesting. I've spoken to several battery factories, and when I speak to them, actually a lot of them tell me that they're not looking to look for a new innovation in their factory because the entire process is already baked in. Everything they know exactly how much is going into each step and like what the flow rate is and everything. And when someone else comes in and says, hey, we can do something 50% faster, they're like, we don't need it because if the factory's already designed. What's your reaction to that?
Exactly. So I think it's a very true statement, and I think it applies to everything that is economy of scale. So the basis of economies of scale or mass production is that you de-risk something on a small level, and then you just scale it and scale it and scale it and scale it. And so it's very difficult to actually introduce something new and something that is so fixed, so rigid, right? And so the only way you can actually implement innovation in such an environment is by being minimal invasive, so barely changing anything, right? And also being compatible with that means compatible with the infrastructure and that is already installed and compatible with the supply chains. So that's the environment in which we operate. And so you have to present something that is small in impact from a production side, but big in impact from a reward perspective, performance, or whatever, cost reduction. Yeah.
And I have a joint question for either Max or Fern, but you're working on the anode, you're working on the cathode. They need to work together in order to be compatible. And so I guess, how much do you talk to each other before you actually meet together at the factory?
So I would say not so much. So I see always, and I think probably maybe, I don't know how much you see that equivalently, Fern, but I also always see the cathode as a means of showing kind of the benefits of our part. So what we always say is like, well, the negative electrode is limiting to fast charging, and so we're agnostic to the cathode. It can be LFP, it can be NMC, it can be LF, whatever. And so as long as you have some cathode material, then that's sufficient. But going a little bit deeper, you're actually right. So for instance, one of our value proposition is that we can go to very high loadings. This is actually where our technology has the largest benefit. But then you actually have to match that high loading with also a high loading cathode. And so this is when it starts to get tricky, right? And what chemistry do you choose? How do you actually make an electrode that's thick also on the positive side? So this is where we typically talk to the cell manufacturer or other companies that to have something that matches our electrode.
Yeah, I would echo this as well. I think historically, any kind of collaboration or compatibility between the anode and the cathode has been studied by the cell vendor, and the cathode essentially engages directly with the cell vendor, and then the anode vendor engages directly with the cell vendor, and then that's kind of the inflection point of communication. But I would echo your statements as well. I think that this is really changing as we see continued progress on the anode side of things with the introduction of silicon anode and other high-loading anode technologies. And what this means from a cathode perspective is that we need to future-proof our cathode. We need to make sure that our cathode is compatible not only with existing graphite anodes, but with continued development in the anode space as well. And so I think on the development side of things, we're beginning to see some collaboration, and I think that's really encouraging.
Cool. Sarah, tell me a bit more about EU battery regulation. Before anyone could manufacture batteries and sell them anywhere without much scrutiny, but now EU battery regulation is coming online this year. Things are going to look very different for making and selling in Europe. So what are companies doing about this? What are they doing right now? Like, what needs to happen in order to make sure that we're all compliant with new sustainable manufacturing?
Yeah, good question. I think it touches on quite a few points that were already made around the challenges that we're seeing that have existed in the industry for a while around looking at the supply chains, looking at performance issues, looking at issues that we have around safety. And so Europe is one of the first countries to kind of come out with a very comprehensive legislation to make sure that companies and battery makers particularly are meeting minimum standards around performance, safety, but also sustainability. And so this legislation is one that's coming into place this year, is one of, across most industries, the most comprehensive regulations around sustainability. And so it covers things that you would expect around carbon footprinting, but it's also going to start ranking battery makers based on their carbon footprint and then setting thresholds that they need to perform above. It's also got huge, lengthy requirements around supply chain due diligence. For example, needing to have tracking systems with your suppliers, needing to have your policy in place, have it third-party verified, so on and so forth. And then also looking at recycling and end of life of batteries to ensure that we can move more towards a kind of from a linear supply chain of like mining at one end and batteries at the other end and then use and then kind of end of life to then creating a circular supply chain where we can have the resources at end-of-life batteries coming back into the manufacturing processes. And so for battery makers, it's both a big challenge, to be perfectly honest, because especially for battery makers that are only just beginning to scale up, they have their core expertise is in technology and scaling up that technology. And so for them to have to navigate the regulation landscape, the sustainability requirements coming in both from the regulation, but also from customers, if you want to sell into a large auto OEM, the amount of sustainability and additional requirements that come in there is a huge challenge for them to navigate. But the kind of bigger picture, I guess you could say, yes, it's a challenge, but if we look at kind of what is the ambition of the industry, it's to build sustainable mobility. And that doesn't necessarily just mean, if we get to a world where we have 100% electric vehicles on the road, is that what we define as sustainable mobility? Or do we say, when we look at what actually the battery manufacturing process looks like, the battery supply chain process looks like, and we recognize that, for example, the production of a battery is actually more energy intensive than an internal combustion engine vehicle from a production standpoint, obviously not from a whole life standpoint. And so addressing these challenges is key to us saying that we want to move towards sustainable mobility in a kind of comprehensive way rather than just saying we want to move there as quickly as possible and kind of not look at the wider context in which we're moving.
Okay, no, that makes sense. But I want to throw a curveball. What happens if in a version of the world where we can't be compliant with regulation because it's too difficult? Like, what does that look like for Europe?
I think there's a reality with how regulation works, that if the industry can't comply, the regulation doesn't exist. And so the way that regulation frameworks are developed is very close consultation with industry. And the reality is that even though this is an exceptionally ambitious regulation, it's actually a lot further below where it could potentially be. And so meeting that minimum compliance is yes, it's a new thing for a lot of companies to deal with, but it is going to become the norm. And what you're actually going to end up seeing is the kind of outliers are the companies coming in saying, we're not just going to tick the box of minimum compliance, but we're going to do what we can to build as sustainably as possible. And that's, I think, also where you see newer companies like Mitra Chem coming in saying, okay, we are not just here to kind of like build this new battery technology, but actually looking at the broader picture of sustainable supply chains, localizing supply chains. How do we build our technology kind of feeding into this ecosystem? But Fern, maybe you've got something to add on how you see that regulation landscape playing in, especially EU battery regulation, but also things like the Inflation Reduction Act.
Exactly. Yeah, I'm totally aligned. I mean, we saw the IRA roll out in the US with incredibly ambitious localization parameters, and then we saw those flex a little bit as there was deeper industry consultation. And so, yeah, policy doesn't move forward without alignment from the industry itself. And we're also seeing a lot of front runners in the battery kind of play forward what this policy could look like to get out ahead of it. Mitra working with awesome companies like Infyos to think about, okay, where is the EU going? And kind of undoubtedly the US is going to follow, and how do we position ourselves well to be aligned? I think also these policies don't roll out, with execution necessary at timestamp 0. They often roll increased kind of scrutiny as time plays forward to give companies the opportunity to continue to innovate and progress with time.
Yeah, exactly. Like something like the European battery regulation comes into force this year, but some of the requirements don't actually come into force until as late as 2035. So we have a long time to get ready for some of the stuff.
Yeah.
But some of it is coming into place in the next couple of years. That's the low-hanging fruit.
Cool. Gavin, I want to shoot it over to you and just ask you, all this battery manufacturing, everything that happens in manufacturing translates to how it affects the end product.
Yes.
So I'd love to learn a little bit more about what people are doing right now in terms of taking these batteries and sourcing them and buying them and plugging them into the different softwares and seeing how it works, and what's the issue with that today?
Yeah, for sure. I think a core part of this is understanding how batteries are developed today. So whether that's the cell or the system, quite unbelievably, a lot of batteries are developed very empirically, a trial and error kind of a based approach. And to me as an engineer, that seems crazy, especially when I started learning about batteries, because we have all these amazing simulation tools. You look at how an airplane is designed today, or a Formula One car, it's almost completely simulated in a virtual environment where you can iterate very quickly and cheaply, and then you design the real thing to validate it. And you look at the battery industry and why that isn't the case, and it really comes back to batteries being ultra complex. Yeah, and having done a PhD in batteries and done many experiments on batteries, where you do the experiment, you expect one result, and you get something completely different. Lots of really unexplained physics. And literally every week at About Energy, we find new physics that the current modeling frameworks, the software doesn't really capture. So there's a lot of work to be done in that space. But what we're trying to do at About Energy is join these dots. Because you look at an application like automotive, for example, and the metrics they care about are meeting the warranty obligations, fast charging, the kind of system power, system performance. But then you take that back to a cell manufacturer, and a cell manufacturer is really concerned about the energy density or the power density of the cell. And then you go the whole way back to material developers, and we talked about earlier. Material developers are often optimizing for, say, the particle radius or the porosity of an electrode, the porosity. So you have this big chain, and each element they're optimizing for their own little niche. And it's not very clear at the moment how changing a particle radius affects your battery lifetime. So it's very difficult, and is what we see as automotive companies really struggling to optimize that system. And I can kind of give you a really good example of where this all kind of falls over. So if you look at cell manufacturers optimizing so heavily for energy and power density that they strip so much aluminum and copper out of the cells that then they have really, really bad thermal performance. Now you put 7,000 of these into a Tesla, and they produce a lot of heat, and it gets really, really hard to extract that heat. And yeah, these cells are really kind of under-designed for the thermal performance. But Tesla, with their beautiful vertical integration, they came out last year with a tabless design, which is actually like fully tabbed. It adds extra copper in, so they lose energy density, but they get amazing thermal performance. And so what we're trying to do is help the industry that isn't so vertically integrated, so the automotive companies working with the LG, Samsung, and much of the smaller manufacturers, to try and help them join all these dots And we spoke about it this morning with Fern and Max to see how we can go from material developers and the things they have to play with, but really what does that mean for the system? What does that mean for the automotive car? So I think there's a lot of work to be done about joining these dots together so that we can actually optimize the whole system.
Yeah, it leads me to actually my final question, but it sounds like you have thought a lot about all this battery data and joining the dots together. Like, if you could wave your magic wand and something were to happen tomorrow, like, what would you create?
That's a tough question. I think what we'd create is like an ecosystem, and that's what we're hoping to build at About Energy. So somewhere, a web platform, a software program where a material developer can come along and they can start optimizing that material for the end application and create kind of one standard database, one standard modeling framework that allows people to optimize for the full system level. And this literally goes the whole way to recyclers, to the end of life and second life, is optimizing for the whole value chain and the recyclability as well. So I think if I could do one thing, it would be to bring everybody together into one room and kind of hash out some standards and ways that we can actually optimize the full kind of battery ecosystem together as one team.
Cool, awesome. We are coming close to time, but I want to give 20, 30 seconds to everyone just for one last comment of anything that you want to say. Fern, you want to start?
Sure, yeah. I mean, I think that one theme that I've seen echoed kind of in everyone's response is a real focus on pace. There's so much the work that needs to be done on the sustainability side of things, on the innovation, energy density, and supply chain side of things. And I think that it's really frustrating how slowly the battery industry can move. I mean, it takes 5+ years to develop a chemistry alone, and then another 5 years to execute on the integration into the actual vehicle and the qualification standards. I think that's something that we're all really working on, be it at the cell to OEM integration level, at the material development level, is pushing forward the standards on how quickly the industry can innovate and move forward.
Awesome. Yeah, related to that, I guess from another angle looking at time, I think the thing I would add is that on the scale of where we're going for battery technology, we're actually still in the very early days of what we're doing, especially when, us on stage are European, US players. The future of where we're going is still very much undefined. And so we still, at this point, have a choice about how we can do it and how we want to do it better than how it's being done today. And whether that's technical innovation or sustainability innovation, I think that's really important as a reminder for the battery industry and for innovators is, don't look too much about, yes, what's happened in the past is important, but there's still so much potential about in the future, and so much will change in the space over the next 10 years.
Yes, so from my perspective, what I want to, I think, kind of like stress is the importance around as well innovation and how it can actually happen. And I think it requires also established manufacturers to kind of like change the way they've thought about things, and when it comes to, in our case, deploying technology to also kind of like have a collaborative approach, because this is something that we oftentimes see is that there's really like a legacy of how innovation has happened, and a kind of like a narrow-mindedness about the flexibility of startups in that acting in that space of how actually innovation can be sped up and also how fast things can be tested and implemented.
Yeah, and I think just to add on to that, just the rate of change in the battery industry, whether that's the materials, the cell formats, the applications, I think it's super exciting where it's going, and I don't think anybody could predict even a few years into the future as to what's going to come along. So I'd say, yeah, very much watch the space. And also please follow About Energy and kind of our trajectory. We're only a couple of years old and we've got a lot to do. But if you want to grab lunch and chat about this after, I'm more than open to that.
Yep, I won't keep you anymore. So thank you for your time, and let's enjoy lunch together.